Hello friends, good morning, good afternoon. In this session, we are going to see Azure Databricks. Okay, so as we seen, there are multiple topics in the Azure Databricks. So we are going to cover one by one. And this is the in this session, I am going to cover introduction about the Azure Databricks. And Azure is the one cloud platform. Okay, and Databricks it is the one tool. Okay, so that is incorporated with the Azure, means AWS as well as GCP as well. Okay, so right now we are going to cover about the Azure point of view. And as you know about the, I have to go about the historical information about the Databricks, means when that tool is founded. And Databricks provides the means their community edition as well as standard and premium as well. Okay, so first thing first, go to the databricks.com and then try Databricks at here, and you have to give the some miss prior information about the miss. We have to download that edition. Okay, so first name, last name, email, then company. These are the some prerequisite information. I'm giving you the some demo point of view. Miss Sagar, means there is a last name, then email ID, and then particular India, and then for which learning point of view or which are going to select that tool. Okay, and then next thing is the continue. So miss on which platform you have to use, or there is another one, means get started with community edition. So in that there is some limited functionality, but you can try that. Okay, so you will get the look like as this, means this is the one I created for it. Means there is a catalog. Yeah, I will show you about the what is the catalog and all these things, but before of that there is a cluster. Okay, cluster is nothing but the compute. So I'm going to delete that, and first of all there is a create a compute. So what I'm telling you this compute first of all, so I'm going through the Spark UI. Okay, that purpose means I'm showing you, right? And then there is a, these are the some versions about it, means runtime about it, means there is a 14.1, and there is a LTS. LTS stands for the long term support. Okay, then I'm choosing the 15.4, which is the long term support as well as stable one. And there are some configuration point of view, environment variables. I will cover one by one. Okay, so create compute. Okay, these are the some means like a different types: notebooks, libraries, event lab. Then there is a after that there is a, after the event log, then there is a Spark UI driver logs. I have to show you the Spark UI, then we can go through the underneath of that. Okay, so correct, yeah. There is a Azure Databricks, okay, and in the Azure Databricks, there is a, in the background there is a Spark, okay. So when I created at here, there is a cluster. The cluster is running right now, and in the background there is a Spark UI, correct. So as I said, means there is a Spark. We have to cover that topic in this session, okay. So I'm creating the one more playlist for the specially on the Spark and Hadoop. Okay, so which will be helpful from the in-depth point of view, so that you will get the complete information. Means there is a Spark related things and Hadoop related things. But right now I'm just covering the main topics related to the Databricks in this playlist. And one more thing, so I'm giving you the quickly recap about the RDBMS, Hadoop, and then Spark. Why these things are came into the picture. First, a basic prerequisite is that we have to download the community edition from the Databricks, as I said. And then second thing is that if we have a means Microsoft Azure cloud light, means there is a free tier available, then means free subscription is available, then that will be a good, so that we can easily avail that. Means there is a Azure Databricks service, we can learn the more things, right? Means there are some, let's say in our space one, I'm means there is a premium tier or a means standard tier as well in that. But from timing point of view, we can download the community edition as well, because in that there are multiple features. If you go through it now, means there is a launch workspace, so you can see multiple things. and there is a from file system point of view. Here is the DBFS, and here are the some ABFS related credentials. Other things are coming into the pictures. Means you can see SQL, data engineering, machine learning point of view. Other features are available from that perspective. Okay, and next thing is that these are the some different flavors about the Databricks versions. Means let's say standard, then there is a means premium tier, and this is the community edition. Okay, right now I am on the community edition. Okay, so here in community edition there are means less menu, means less options are available, but from means as a just information point of view it is sufficient. Okay, and then in the background once cluster is created, there are some different tabs are available, means Spark UI. So I have to show that, and then we can go through the means historical information. So till the time it is creating, so I'm going through the one thing, means what is the Spark and what are the different things about it, and then we can go through the Spark Hadoop, and then there is the next thing is that the RDBMS. So I have to give the prior information about the other system as well. Okay, and then you will know, yeah, what are the different things. Okay, in Spark and in Hadoop, and then when RDBMS. Okay, so previously in the 1919 or up to the, yeah, up to the 2005 or 2010, we can say, yeah, we are using the mostly RDBMS data. Means there is a we have a data in a structured format. Okay, structured format in it means there is a columns, rows, correct. So such a kind of information means it is a well structured. But after that, what happened means there is a we are getting the data in a different formats like audio, video, or a semi-structured data as well. That's why means there are the V3 concepts is come into the picture. Means V3 is nothing but the velocity. First V is the velocity. Means we are getting the data in a large amount of, right, and this is the first V. Second V is that the variety of data. Okay, and then volume of data. Okay, there are other views as well, and miss these first v are important, miss first three views are very important. And velocity means data is generating more, means after the 2011, and then there is a variety of different data. Means we are getting the data in a structured format, semi structured format, unstructured format. First of all, structured format is nothing but these, right? And then in terms of the semi structure, it means like a JSON file. Okay, or a XML file. These are the some semi-structured format, and non-structured format means there is a some audio file, video file. Okay, as well as audio or a image. Okay, so how we can store that data? So that's the problem. It's come into the means after the 2010, right? And so and there is a large amount of data also. Means there is a we are getting the data in a high scope as well, and then there is a different variety of data as well as very large amount of data. So how we can handle that data into the RDBMS? That's the problem, correct. That's why Hadoop is come into the picture. And uh, what is in by Hadoop? So you miss if we are saying it as a large amount of data, we have to handle that things. So there is a called as concept, means there is a big data. Big data means large amount of data, huge amount of data, and it having a different formats, as well as there is a velocity is increasing. Means there is a miss in terms of the petabyte data is generated per day. So or means that's the reason. Means this we have to handle that situation, correct. And one more thing, there is a when we are coming to the Hadoop from RDBMS, so there are other things as well. Means from the data perspective, okay, different variety of data, and then there is a scalability. What is mean by scalability? So let's say in RDBMS point of view, it is the RDBMS system, and this here is the one database server. Okay, and one RDBMS server, there is an engine. Okay, in background there is an engine which performs the all the operations. And whenever there is any system, so we require two things. One is the storage and another is the compute. Means there is a compute power is required to perform that operation. Okay, so storage point of view, we are using the hard disks. Okay, in RDBMS point of view, suppose I am considering SQL Server as a RDBMS. Okay, and in that there are some means in the background MDF and LDF file are required, and where are they stored? Means on hard disks. Means even if we have a hard disk about the 2 TB or a 4 TB, or there is a means number of, based on the requirement we can add the hard disks. Okay, that suffice, no any problem. Means suppose we have a means database volume, means database size around 5 TB, then we need to add the, means there is again 2 TB we have to add, means it will be a more as a 6 TB point of view. Okay, but from computation point of view, we required RAM and then processor. These are the very important things. And then means there is a RAM, let's say, means from 32 GB, or let's say 64 or a 128 GB point of view. Okay, and then there is a processor point of view, there are some Xeon processor or other means core processor. Okay, so we can add that things as a hardware point of view. Okay, but there is a certain limit, right? Means on a one machine, if we are going to add that things, means there is a one database, and in, first of all, I am calling it as a server. Okay, one SQL server, one SQL server having a multiple DB databases. Okay, and one database will occupy, there is a some storage or some compute RAM, miss RAM processor. Okay, so there is a some limit, means on a, there is a vertical growth, correct, and that will be available on one local system, right? And there is a means suppose that data is replication factor, correct, means suppose that data is means this is the primary server and one is the secondary server. I'm, yeah, this is the replica of that server. I'm calling it as a secondary. But there is a, if any issue is occur, primary get disturbed or there is a problem occur, then it will switch to the secondary. It will take some time, or there is a lagging or completely crash the system. Then we have only one data, means only one copy of the data at here. Okay, so that is the one thing. And from processing point of view, it will target only one server. Okay, means there are other things as well, but means let's say from computing point of view, it will target to only one, right? And that fails, then all will gone, means our system will down, right? That's the problem. So from scalability point of view, there are two terms. One is the scale up and one is the scale out. Scale up is nothing but the, suppose there is a one database and we have to add the some miss RAM, or there is a memory inside of that. Then we are calling it as a scale up database. Okay, and then there is a scale out. Scale out is nothing but the horizontal things. Means one machines we can add, and then there is a horizontal way, and here is the vertical way. Correct. Means if we are going to add, there is a RAM cores or hard disks, then it is in a scale out mode. It will miss, yeah, obviously it will use the performance, and but it is a single system. But in that there is a scale out, in that there is a commodity hardware we can use, and then there is a miss, it is the local system, means monolithic approach. Okay, and only one system in that. And here, or we can call it as a monolithic approach. Okay, and here is the distributed computing system. In terms of the distributed computing system, so performance is the main important factor. Why? Because it helps us a lot in the performance point of view, because data is segregated on a different machines, and there is a chances about miss data is available on other machines as well. And so I'm giving you the some very important miss, there is a some sample about that. There is a, suppose there is a one file, okay, and we have to process that file, and the file is available on, means there is a 30 TB of file. Okay, size is a 30 TB, and there are three machines. which will work parallelly. Okay, and then they will process that data. Here means we are segregating that data on a different machines. We can process that data. Okay, I would say there is a process of data. Okay, here is also same, processing the data. Okay, and then after that, once the data is processing done, then it will take 1 hour. Okay, 1 hour, all the things are in a 1 hour, and finally we will get the data in a 1 hour, right? But in terms of the local system, what will happen? Suppose we are providing the 30 TB of data. Okay, and there is a some file, means CSV file or any, right? And we are passing to the one system. Okay, it will process that data. Okay, means there is a some operations is running, and then there is a, it will require 3 hours. Why? Because based on the, means one machine and other three machines, they can do their task in a very quickly manner. Why? Because it is a segregated, and same data it will, miss one machine taking 1 hour to process 10 TB of data. So based on that, we can say, yeah, this approach is perfect and fine. Why? Because there is a distributed system, three blocks of it. Okay, one file having a three blocks. Okay, one is the, I'm going to draw different so that it will be helpful for your understanding. This is the one cluster, and cluster having the four nodes. Okay, I would say worker. This is the driver. Okay, and these are the workers, and this is the complete known as the one cluster. Okay, I'm calling it as a one cluster. Okay, and these are interconnected. Okay, and yeah, there is a three files, right? Means there are three chunks. One is A, right? We are sitting at here. Okay, A is, then there is a B also. Okay, and B. After that, B is right at here. Okay, and then last one is the C, and C at here. Okay, so what will happen in this case? There is a, means we can segregate data among all customers, and there is a three replication factor, means a and here A. Suppose it is breaked, means there is a third worker is break, or there is a, means in future as well, means there is a, means very high means we have to process the data, or there is a request are more. So instead of this, we can, there is a hardware problem is occur, or there is a large number of process we have to do that, then we can pick the data from here as well. Okay, so we can have a high availability of data, and then there is a performance is also better. And in the background, there is a one thing is came into the picture called as a mapper, miss map reduce. Okay, this is the heart of Hadoop system. I will create point of view. Okay, means there is a processing point of view, and there is a storage point of view. They are using the HDFS, Hadoop distributed file system. Means in the background there is a distributed computing they are using. Means as I said you, there is a on local machine there is a monolithic approach, but from the distributed computing point of view, yeah, Hadoop is using that. And then there is a H stands for Hadoop, and then compute point of view, map and reduce. Map and reduce it nothing but the, means mapping and reducing, mapper and reducer. Means suppose there is a one file, it will divide into the multiple chunks, then do the operation on that data. Means there is a perform operations, means like a shuffling. Okay, and then once that particular shuffle is done, then there is a, we have to reduce as well. Means there is a, we have to calculate the result as well, correct? So that is nothing but the, here is the mapper, here is the reducer, and here is the shuffle. Okay, and then in the, this is the result, and this is the input. Okay, so this strategy is followed in the Hadoop point of view, and there is a oh, yarn means suppose we are giving the request to the system. At that time yarn is playing the main role, means yet another resource negotiator, means it will based on the availability it will submit the job, or it will do in a pending state. Means there is a suppose there are 10 requests simultaneously we are getting, so one is processing, so two is in a wait state, three in a wait state. One by one we can process that request and we can give the result to the customer. Okay, and here is the customer and here is the cluster, means this is the yarn, means yarn having that data, means who is available, who is not available, or there are some workers having that data or not, or means based on that it will do that things, and then you will get the at the end result. So this is the rough architecture about the Hadoop system, and provide the some request and submit the request, and this is the Hadoop framework. Okay, so in Hadoop framework, as you know, I said HDFS, Hadoop Distributed File System, and from compute point of view, it using the map reduce. Okay, so and there is a at the end you will get the result. Okay, these are the things. But in terms of the map and reduce, mapper and means there is a map reduce is the functionality. So what it does actually, when we are getting the data or a file in terms as a input, so we have a data in a multiple machines. Okay, so multiple machines we have a data, right? And then there is a RAM as well. Okay, RAM means memory, means it will perform the operation in a memory, means here is the disk, here is the RAM. And first of all, means whenever disk is nothing but means multiple machines we have a disk as well as there is a RAM, right? But whenever there is a perform operations, means like we have to calculate that things, so this data is shuffled from disk to the RAM, again that will write that data to the disk again same second thing is happen, means from the disk to the RAM, then RAM to the disk again. So same thing happen for the first machine, second machine, or a third machine, or a means where that data is located, correct? And then there is a means shuffling is taking time. So shuffling is taking time means there is a data read write, and then we have to perform the computing operation at here. Okay, means there is a you are giving us some operations like 3 plus 2 is equal to 5. Okay, so you are giving that data, means that is the binary conversion in the background, means there is a 1 0 data it will compute at here, means 3 plus 2 is means whatever the operation at here, but data is at here. So and then at the end the result 5, which is again going to write into the disk over here. Okay, means into the disk, and then at the end we are getting the result. So there is a some in and out operations, IO operations are happen between the RAM and disk, so that why it's taking time. So to alternative of this means Spark is come into the picture. Okay, so next is the what is the difference between the Spark and Hadoop. Okay, so first thing first, means as you know from the result oriented point of view, means there is a large number of IO is here required. Okay, large means input operation is required, but in terms of the Spark na, there is a no any storage. Okay, means all the operations are happen in the RAM. Okay, means there is a all, suppose we are giving the file to the Spark, so it will do operations on means that particular machines, and it having their own memory, right? And then there is a data is situated at means like a on, this is the I am considering it is a RAM, and there is a processor as well, and which can compute that things. And after that there is a data point of view, I am considering Azure at here, means it will support Spark will support HDFS, Azure Blob Storage. Okay, then there is a S3, then there is a DBFS, Databricks file system. Okay, these are the some file systems which can support by the Spark. And then as I said, here is the means storage. Okay, so storage point of view, it help, and in that there is a means when it pick up the data is available into the RAM, it will perform the operations in the memory only. Okay, I am calling it as a computation. Okay, on top of that, so no need to overwrite, means read the data, write the data. Just we have to read data one time. Okay, read one, then write one. Okay, so only two things are done, and then we are getting the result at the end. Means so there is a IO is low as compared to the MapReduce, and yeah, that's why means there is a Spark is much faster as compared to the Hadoop. That is the one thing, and there is a in memory processing. All the processing are available into the RAM. Means as you know, when we are comparing storage and RAM. So who is the faster? Always means there is a RAM is a win, and storage having a less, because this is the in memory operations are we are doing, and that's why we have a laptop it having the 500 GB of hard disk. Okay, and then there is a 4 GB of RAM. Okay, and there is a or 8 GB of RAM. Why? Because it performing the operations, computations, and all the related things with the help of this memory, right? This is the storage, and this is the memory point of view. And if all the operations are happening within a RAM, that will be a more faster. So then next thing is that what are the different advantages? Means like from in-memory computing. Okay, so in-memory processing or computing, yeah, we seen faster. Then lazy evaluation or lazy computation means what it does actually when show or there is a count or a collect. These are the some methods. Okay, so when that particular method are not calling, till that they are not taking any actions. Okay, so that is why means there is a in the practical I will explain you so that you can get it clearly. Okay, then environment independent, it nothing but the means open source, and it is available means there is a on let's say my laptop is on a window. Okay, and there is a Python I can install, and then after that on Python I can there is a Spark I can install, right? So it will be available, and then on a Hadoop environment also you can easily means there is a Linux OS, and then there is a Hadoop you install, then on top of that there is a Spark you can install. So there is a means environment independent, there is a nothing problem. And ML support means machine learning point of view, cloud support, there is a means three clouds major are supporting. Then customization about the serialization is nothing but the means there is a serialization point of view, means Java related point of view. There is a there are multiple people who are working on a Java. They know about the serialization on deserialization, Parquet, ORC. These are the some file formats means compact, and they are important from the serialization and deserialization point of view. Okay, and then easy to read and write the data from the sources. Means they are having multiple connectors. With the help of that we can it supporting to the means like a JDBC, ODBC, or there are some means connectivity point of view. It helps us a lot. And then there is a graph DB support or a SQL point of. I hope you got the some clear understanding about the RDBMS, Hadoop system, and then Spark. And I have to give the some practical session about the Spark. Means let's say this is the community edition, and in that there is a miss click on a new and then notebook, then this is the UI. Miss you can see and start the Spark session, or miss there is a miss based on the, it is not required every time, but whenever there is a Databricks shell is calling, so you can see there is a what is the version, then there is a Spark UI, so you can see the Spark UI at here. Okay, and first of all if you, yeah, click on here and then click on the Spark UI session. Okay, till the time, yeah, there is a means what is performing in the background, so you will get all the details about it. And Means all the things are running in the background, means like a framework point of view. And as you know, the Spark is the computing framework, means unified computing framework. And unified it means there is a, means it is supporting to the means different means machine learning, data analyst point of view, data engineering point of view. So retrieve the data, perform the operation, and then machine learning point of view, they can predict the results, okay, or analyze the data, means analyst point of view. It is the unified computing environment, okay. And then next thing is that I'm just reading the data from the one CSV file, patient CSV data, okay. And there is a catalog. Go to the DBFS in file store. First of all, file store, and then there is a click on a file store, and then table, and then after that upload. Here you can click on that, and then you can upload the file, okay. And once that file is uploaded, and then that particular patient CSV is come at here, okay. And once that done, then you can see the path of it, means copy the path, okay. Copy the path and then close it, okay. Here go to the catalog, and then you have to just put that particular path over here, okay. File store. DBFS stands for the Databricks file system, and it is the internal one, because it is the community edition and they are providing that storage, okay. And here the data frame is created, and then you have to just click on a display is nothing but the one action, means there is a, as I said now, means there is a some operations, means lazy evaluation point of view. If you are giving there is a patient one, yeah, of course it is definitely check, but there are some other transformation on doing that, so it will wait till that particular display is not triggering, okay. So that is nothing but the lazy evaluation, or we are calculating it as a count, means it will give the whatever the number of records is available into that particular data frame. So there are only 10 records, okay. So such a point of view, we are getting the means we can run the program into the Azure Databricks. So basically, one by one, I'm going to show you about the, means as I said in my uh, session, there is a Databricks, and then there is a, first of all, introduction to the Databricks, why. And one more thing I have to say, let's say in catalog perspective, if we run that particular program, then there is a, in background there is a Spark jobs are created. If you go through at here view, and then what it does means it scan the data, means there is a whole stage code generation, and then there is a full name, your description at here, and then there is a what it does, means there is a shuffle operation are done, in or out are done, so you will get complete information, means there is a full name about, okay. And so I'm just going through stage, and yeah, job and stage. Job, stage, and task, these are the three main important about the DAG, means directed acyclic graph, means as you know the execution plan in SQL Server, so same thing is happen over here. And means first scan RDD, then there is a map partition RDD, okay. And then load the native methods, and then with the help of Java program, okay. And so there is a GC, okay. And then duration, how much is the time is required for that particular to perform that operations, means there is a status, okay. And one good thing is that, means suppose there is a in between a machine is failed, means in, I think I forget to uh, tell you about, means suppose in Hadoop there is a one cluster, and is any one machine is failed, so it is completely, means he is not able to recall that things. But in terms of the Spark, there is a RDD, means resilient distributed data set, means it will go to the past state, and then it perform, means it generate the RDD, and then we are getting that particular results. So that those are, means in the one separate series I will explain about the complete entire session about the Spark related things and Hadoop related thing, okay. But from the overall point of view, RDD is nothing but the resilient distributed data set, and then whatever the operations are done, means it can suppose it is failed or there is a node is failure, so uh, it will go to the previous state and it will regenerate that particular RDD again. So no need to, miss the program will not fail, and which is calling it as a fault tolerance. And yeah, storage point of view, how much time is required, then environment, then executors, how many executors are required to do that operations. Okay, so you will get complete information in this Spark UI. That's why I up the cluster and I shown you, means in terms of the compute na. So here go to the cluster and then there is a Spark UI. Okay, so Spark UI you will get complete information, whatever the job ID has came from the user perspective, means we run that operations, after that we run df.count. Okay, and then how much time it took, and yeah, so from the analysis point of view we can easily go through that. But this UI or miss whatever the configuration, you can set it at here as well, but if you don't know, so miss day by day you can understand it more. And um, this is the Spark UI, means this is the entire infrastructure they built. Means right now, means we are using the Databricks Community Edition. So Databricks Community Edition, they did it whole things in that. We have to just use it from the miss notebook perspective, and we can miss day by day we can deeply go into the complete environment, and then you will know what is the backend structure about the Miss Spark architecture or and from the next session, I'm showing you all the demo in Azure platform, means so that Azure platform is required, and then we can easily see what are the different workspace and it having a multiple options as well. Means if you see at here, means these are the SQL editor or a SQL warehouse dashboard. So one by one we can go through that. Means as per our topics I suggested at here now, means there is a workspace, what is that, then notebook, library, repository, types of cluster, all purpose cluster, job compute or job cluster. Okay, so yeah, that's it from my side. We can meet in the next session. Thank you very much.